you go through this one then, excuse me. Anyways, as you go through this one, you would circle the B's, okay? So we circle these through, and that's showing us that we have an angle B and we have side B to work with. This first problem is forcing you to then find angle A because you have little side. So what we do is we write it out like we did yesterday. Sine of 86 is to side of 20. Sine of A then is to 10. When you're solving these things through, this now means you have to basically get the sine value by itself. So you have to multiply by the 10 and write it out. So you'll have 10 sine of 86 divided by 20 will give you the sine of A. Here's where the calculator comes in. From here, after you've written all this out, it's all calculator. Okay? Go to your fraction bar. Oops. Ten sine 86 over 20 and hit enter. This is some crummy decimal that equals the sine of A. Remember, anytime you're trying to find an angle, you have to use the inverse function. Second sine, second answer, because we're using sine. That gives you that angle at 2992. So in the problem, you would write in where you had 2992. Now you have 2 out of the 3 angles of the triangle. How many degrees are in a triangle? 180. So you just back out those 2 angles and you'll be left over with angle C. I know it's going to end in a 0.8. Is it 35, I think? I think we did this earlier. Help me out here. What'd you guys get for angle C when you subtract those out? 18. For number 4? Yeah. Okay. I would say, oh, this doesn't sound right. Okay. So now you have angle C. So now you use law of sines again to find side C, reusing the sine of 86 and the 20. So you get the sine of 86 and 20. Always reuse what you circled to start the problem with. Sine of 64, oops, 0.08 is to little c. And like we did a bunch yesterday, anytime that you're trying to find that side length, we're always going to do the change along the diagonal and then multiply by the denominator. Okay? It's the same process every time. That's what's kind of nice about this. Once you get the knack of writing it out, it doesn't change, it's just the values. Sine 86. Again, press some buttons. 20 sine 64.08 over sine 86. And that's your 1803. Right, that's your sine. Remember, the only really thing that you can do to see if you're on the right track is to go back and look. Is the biggest angle across from the longest side length? Well, the biggest angle here is 86. Is 20 the longest side length? Yeah. The next biggest angle is the 64. The next biggest side length is the 18 and change. And so on. Yes, ma'am.
So for every angle that's
whenever you find an angle, yes. Whenever you find angles, you always have to inverse whatever you have. Just like we did with SOHCAHTOA. Okay. When we did SOHCAHTOA stuff, if you had, let's say this was 7 and this was 15, this was your theta. You'd circle, you drew, so you knew that the theta was the inverse sine of 7 over 15. The only difference between this stuff and this, these side lengths were usually clean numbers. Now they're just crappy decimals. That's the only difference. Okay. So it's here we could have done the same thing. We could have done 7 over 15, hit enter, second sign, second answer. We would still get the same scenario. It would still work. But since we had real clean numbers, we can just type it in remote straight. This is just a little more buttons. Okay, second.
So when you do the sign, you know, you have to, you gotta do that for every angle too, like you have to sign.
If you have to find an angle and you're using the law of sines, yes. Okay? And that's when we start to realize the law of sines only works with basically angle side angle, where you had two angles, you have two angles in a side, or side angle, where you've got two sides in one angle. And that one angle is always across from one of the sides. That's the only way that law of sines works. You have to have an angle and the side opposite known. Otherwise, you can't use it. Okay. Were there another one at all you wanted to look at? Any other questions on these? Yes, ma'am. Sure. I think it was the other one people had questions on as well. Okay. In number 2, this is what would be an angle side angle. Two angles, and you've got the side in between. So what this one is doing, what this is doing, it forces you to find the angle first. But in this case, do you have to do any trig to find the angle? No. You've got two angles. How many degrees are in a triangle? 180. So you back out the two angles that you have. So you subtract the 59 and the 24. That's what? What was 37? 97. Thank you. That gives you 97 at angle C. Now, do you have an angle and its side opposite? Yeah. So you use those two to solve for the other sides. So you started out with sine 97 is to 22, as the sine of 24 is to little a. Sine of 97 is to 22, as the sine of 59 is to little b. And the reason why I wrote those both out, both parts here, is because since I'm finding side lengths, the manipulation of the equation is going to be the exact same for both of them. The only thing that's different is numbers. Okay? Exchange-o, change-o, multiply by the denominator for both of them. Okay? So little a will be 22 sine of 24 over sine 97. Little b, 22 sine of 59 now over sine 97. Okay? If you know that you're finding two sides in this case, there's no harm in writing out what you're going to do first before you press a bunch of buttons. Okay? So just go to the calculator, fraction bars. Let's see, fraction bar, I have 22 sine 24 over sine 97. There's my b, 9.02. Oh, sorry, a, excuse me. And then b, again, fraction bar, 22 sine 59 over sine 97. And 18.999 is? 19. So back in our problem here, little a was 902, this one was 19. Does the biggest angle have the longest side length? The smallest angle have the shortest side length, and so on. And that's what we're looking at doing. All right. Thank you, sir. All right. Is that on that one? Yes, ma'am. For what? It's always the angles. The big letters, the capital letters are always angles. Those always go top because the sign of the angle. The sign opposite is always the bottom. That's always the rule. Okay. Angles on top, sides on bottom. So what happens then today is the scenarios that this doesn't work, but we do one step to make it work. For example, it'll look like this. I kind of got this on sequence by mistake. It'll look like this. This is side angle side. I have the included angle. Okay. So what happens now is we're going to start talking about what's called law of cosines. Law of cosines is when law of sines doesn't work. We're going to use it when you have side angle side, and we're going to use it when we have side, side, side. All right? What's weird about law of cosines is that it looks god-awful as we write it out. Once you do it a few times, you start to recognize the pattern within it, and it's really easy to break it into smaller chunks. Once again, you've got your three sides. Little a, little b, little c. Remember, angles are always opposite. Angles are always opposite the sides, carrying the same letters, just lowercase, uppercase. And what happens here is, depending upon what information you're given, there's three variations of the law of cosines, where law of sines was all basically the same thing. Sine of an angle over a side, sine of an angle over a side. You just kind of mix and match, were you with A's and B's, or with A's and C's, or B's and C's. You just kind of knew which ones to pull apart here. In cosines, on the other hand, there's three different versions of the same equation, and you just have to choose which one you're working with, depending upon what letters you have. For example, let me write out the three for you and see if we can find the pattern here. Yes, they're really long-winded. Yes, there's a lot going on with the law of cosines. But the idea here within these three variations, let me show you here, within the three variations of them, I want you guys to notice that, oops, the lowercase c and the uppercase c, the angle and its side opposite are always on the tails. Lowercase b, big B, they're on the tails, they're on the both ends. Little a, big A, they're on the tails on both ends. That remains constant. The reason why that is because depending upon what scenario you have, when I go back to the question we had here with our triangle A, B, and C, I have angle A, so that 45 is my little a, angle C, 43 is my little c, angle B, there's my little b. When I look at this problem then, what big angle do we know? B. What little side don't we know? B. See how that's kind of coincidental? Which of those three versions of that equation do you think you would write out? Yeah, the one with the B. The one with the B's on the end. The reason why we're doing that is because we have the angle B, we need to find the opposite. If this was over here at A, I would do something different. It's just dependent upon the problem. If you've got the big angle, you're going to use whatever that letter is version. So I would write it out. B squared is A squared plus C squared minus 2AC cosine big B. What's up?
I would say law of cosine.
Cosine, yes. Yeah. Kind of convenient, isn't it? Law of sine, go figure. What does it have? All right. So now, what value don't you know in that whole string? The only one in this whole thing you don't know is little b. So what's A, according to our diagram? 45. So I would write out b squared is 45 squared plus little c, 43 squared, minus 2 times times 45. Get in the habit of using parentheses for the multiply part here. It helps keep things really clean as you type it in. And the angle we have is 88. Are there any variables on the right-hand side of that equation? Nope. Since there's no variables on that right-hand side of the equation, you can literally type all of that in the way it's written. That's the trick. Okay? With side angle side, when you have side angle side, this method is you type it right in. And then square root it. Here's what I mean. If I take my calculator out and I type in 45 squared plus 43 squared minus 2 parentheses 45, close, open, 43, close, cosine 88. We're so used to hitting sine right now, I wouldn't be surprised if some of you guys accidentally hit the sine button every once in a while. That's why it's important to write it out. Okay? And then I hit enter. You get some crummy decimal, 3,700 something, and so on and so on. Okay? That value equals b squared. How do you get b then? You square root it. So again, remember how we've always used the answer button? Second, square root, second, answer. There's b, 6115. When you use law of cosines, if you're trying to find a side length, all you're doing is you're typing it all in, then take the square root. Okay? That gives you a side length. Now if you look at your diagram, do you have a side and an angle opposite one another? Which means, what are you going to use now? Exactly. Then you use law of sines. There's one little trick I want you guys to get in the habit of doing. Every time you use law of cosines, if you're doing side angle side, you find whatever side they give you, whatever side they're trying to force you to find. Okay? The next angle you guys find, always find the bigger of the two that are left. Okay? Always find the bigger of the two. Which of those two angles will have to be bigger, A or C? Which one? A. Why? 45 is bigger than 43. Remember that rule? Bigger, and so on. So whenever you get to find the next angle, always find whichever of the two is going to be bigger. The reason isn't so much for geometry for right now, but when you guys get to Algebra 2 next year, there's certain reasons why you do that. Okay? So that way, whenever you get to Algebra 2, someone says, "Oh, hey, find the next biggest angle," you're like, "Oh yeah, Murphy said that for some reason." So just trying to get you guys ahead of remembering. So sine 88, 61.15. Sine of A is 245. By now, you guys should be all okay that all I have to do is move that 45 up to the numerator and use my calculator. We get 45 sine 88, 61 and change. Now, again, I got to find an angle here, so what will I have to do at the very end? Inverse, yeah. Got to use the inverse at the very end of all this anyway. All right. So go back to your calculator, fraction bar, 45 sine 88 over 61.15, enter. Crummy decimal. Take the crummy decimal, second. Sine now, don't forget you're doing sine this time. 4735. And now do you have 2 out of the 3 angles of a triangle? How do you find the third? Yep. Did somebody not get 40? Did I type that wrong? I hear like rumblings. Was that okay? So yeah, at this point here, all you do is add those up and subtract them from 180, and it gives you your leftover for your angle C. What do you get when you do that? Maybe a calculator would be helpful, guys. Come on. Sometimes here. what was it, 47 and change? And 44.65. Once again, the only real context you can take from this is the largest angle has the biggest side line, the smallest angle, the smallest side line. Other than that, there's really not much you can do, okay? Aside from really trying to do some weird things, all right? Law of cosines takes a little while to get used to. This is the easier of the two methods that you can work with law of cosines now, all right? All right? Try another one. Same idea, okay? Excuse me. Same idea. Excuse me. We have triangle ABC. Notice how this is what I would call a side angle side. You have two sides and the angle in between. Label your sides. Angle C, angle B, angle A, little a. What angle do you know? C. So we would write out a form of the law of cosines with the C's at the tails. And again, the only thing we don't know is little c. When we don't know little c, that means all we have to do is type all of that stuff in, hit enter, and take the square root. So let's see, little a is 9. Little b is 4. And it's a lot of buttons. Okay? It's a lot of buttons. 9 squared plus 4 squared minus 2 times 9 times 4 cosine of 128. Oops, I just typed 28 by mistake. My c squared equals 141 and change. Did you guys get that far? Now I just take the square root. Square root of the answer. There's your side C. 11.888 rounds to 11.8. Now you have an angle and a side opposite. Which angle do you find next, A or B? A, yeah. Now you use law of sines to find angle A first. Always go in order of the angles. Move the 9 up. We'll go back to, oh, look at that, more buttons. Fraction bar, 9 sine 128 over 11.89 crummy decimal. To get the answer then, we just take second sine. We're using sine now. And that's, a lot of times you just get, you have to make sure you write down what you're doing so you can remind yourself what button you gotta press in the calculator. $36.62. So you have 2 out of the 3 angles. Add up and subtract it. 0.38 and 15.38. 38? That version of law of science is pretty straightforward. Okay? It's when you got to find the, I'm sorry, law of cosines. That version of law of cosines is pretty straightforward. You type everything in, square root it, and then you just jump the law of sines. Yeah. The weird part, the weirder version of it is when you got to find the angle. Okay? When you have to find the angle, you have to break it down into a smaller multi-step equation. Okay? For example, let's look at this one. We'll use this one as our first example like this. When you have side, 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 that's the weird version of law of cosines. It's not that it's any more complicated. The only thing is that it just takes an extra step to go and do it. All right. So if you have side, 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 the one rule you have to always remember, that means you don't have an angle. So that means you have to figure out what angle do you find first. If you have side, 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 the one rule will be always find the largest first. Okay. You have law of cosines, you gotta find an angle. Always find the largest angle first, and then when you get that angle, you use law of sines to find the next largest. Always work your way down in order, largest to smallest with law of cosines. Okay. So if I'm looking at this triangle ABC, little a is 4, little b is 6, little c is 5. Which of those three is the largest angle? B. So we write out the law of cosines in terms of b. B squared is a squared plus c squared minus 2ac cosine of, where we have b. Okay. In this case here, you've got b, a, c, and big B. So you've got 4 variables. You know 3. Fill in the blanks for the ones you know. 6, 4, and 5. This problem now becomes kind of something that looks like this. If this was your equation, what would you do first? Subtract 3, good. You subtract your 3. You'd rewrite, and write 11 is negative 2x. What would you do then? Divide by 2. The negative 2, excuse me. And then you guys press buttons in the calculator, you get negative 5.5 was your value of x. You okay with that? That's not anything different. What's different here is that this is broken into 1, 2, 3 parts. What I want you to do is simplify those 3 pieces first. What's 6 squared? 36. There's a reason why I want you to do this, and you'll see this real quick. 4 squared plus 5 squared. Good. Minus 2 times 4 times 5. 40. Times the cosine of b. A minute ago, I had 3 minus 2x equaled 14. Could I rewrite that as 14 equals x? Can I combine the 3 and the negative 2x? Why? Because there's an x, there's a variable here, right? Can I combine these two? No, because I'm multiplying by some variable. Same rules apply. What's that? Not yet. Think of this in terms of a two-step equation. What would you move first? Yeah, subtract the 41. Oh, okay. Subtract the 41. Now you have negative 5 is negative 40 times the cosine of b. How do you undo multiply? 5. Isn't this just going to give me some crummy decimal? Well, not super crummy, but it's crummy-ish. If you type that in, I get negative 5 divided by negative 40. I have some decimal. That decimal now equals the cosine of b. How do I get b by itself? How do you find an angle again? Inverse. What function are we using though? Cosine now. I've got my crummy decimal equaling the cosine, second cosine, answer. There's my angle. That's the weird part with cosine. When you find the angle, you have to break it into smaller chunks. And don't worry, we'll do a couple of these examples like that to get us started on how that setup works, okay? Once you get a feel for it, you'll realize you cannot combine those two values together, okay? So my b value is 82, 82. And that was b, 82. And I heard someone saying, now you're going to use what? Law of sines. Because you've got an angle and a side opposite. Which angle are you going to find next? C. You're going to find C because the side opposite C is bigger than the side opposite A. We use this guy as our pivot, if you will. The sine 82.82 is to 6. Sine of C is to 5. You're back to what you did with law of sines. So, like I said, I know that law of sines can be a little wishy-washy, a little weird from time to time, but you're going to get a lot of practice at it with this stuff anyway, because you have to use it after you use law of cosine. All right. So we type that in with our fraction bar. Uh, 5 sine 82.82 over 6. Crummy decimal is the sine of an angle. Inverse it. $55.77. You have 2 out of the 3 angles. Subtract them out. What do you get? And do angles and sides match up? Hopefully they do, because they should. Whenever you have to find the angle, break it into smaller chunks. You can't type it all at once. You cannot combine those terms together. Okay, you have to separate them. You have to do them in multi-step. Okay, all this will not work. Just like you couldn't combine, like I said earlier, when we had 14 was 3 minus 2x. I cannot combine these two guys together because one has a variable. Same rules apply with the word cosine of a variable. It's just finding some crummy decimal. Okay? Oops. 1917. Same idea, different numbers. Which one is it forcing you to find first? C. Okay. You always start with the biggest angle. We'll always start the biggest angle. So first thing, once you figure out what that angle is going to be, when you have just the three sides, you write out the formula in terms of cosines. So we'll write out the version of the cosines with the C. Okay? Fill in the blanks. And then break it into three separate parts to simplify first. If it's helpful, underline the three chunks. 19 squared, 11 plus 17 squared, and then the 2 times 11 and 17. Break into easier pieces to work with, okay? And then go about it. 19 squared was 361 if I'm not mistaken. 11 squared and 17 squared. Or 10. Minus 2 times 11 times 17. Right. Do not fall in the trap of trying to subtract 410 and 374. It does not work that way. You have to move the 410. Okay. How do I move it? Go. So we subtract it over. It's negative 49, is that right? Is now the negative 374. That's another thing that you guys will forget from time to time. Got to remember that that minus sign is there to bring it down as a negative. Okay? Don't forget that. Once you move that first part over, that number in front of the cosine will always be negative. So remember to rewrite that down. Okay? The reason why that number is always going to be negative is because can your side lengths ever be a negative value? You're always going to be multiplying 2 times 2 positive values, so it's always going to be negative. So lastly, divide out. So now you've got this chromidecimal that equals the cosine of C. From here, it's all calculated. Negative 49 divided by negative 374. Chromidecimal. Inverse it. Second cosine. Second answer. And that angle is 82.47. A lot of buttons. Which angle do you have to find next? A or B? B. You just use log sines now to find angle B. So you switch gears, you rewrite it in terms of sines, because you have your angle and opposite. Which means you have to move the 17 up. Chromidecimal is the sign of B. I inverse it. Okay. And just always pay attention. Are you working with sines or cosines? Because now you have them both. So you don't hit the wrong button. Oop, I forgot to hit my answer. Done that twice then. And I get 62.5. And once you get two angles, I say 0.5 or 0.5? 0.5, thank you. Just add them, subtract it, and you get your last angle. Remember, law of cosines, it's not any more overly complicated than what we've been doing. It's just, there's two versions of it. You're either going to find a side or an angle. If you got to find a side, that's the easy one. Throw it all in the calculator, take the square root, and there's your side. Go to law of sines. If you have to find that angle, find the biggest angle first. But remember, when you do that, then you have to break it in those three different pieces, move them individually before you do your inverse, and then go to law of sines. Okay? There's really no other trick that I can show you with that. All right? Tomorrow, we'll use, you know how we did an elevation depression, we did some pictures, we did some word problems like that? We'll do kind of the same thing with the law of sines and cosines, where we'll draw the pictures and see which one we're going to wind up using. They're really visual. You don't have to solve the whole triangle, you're just usually finding one part of it. But on this one here, I do want you guys to change one of these problems. I didn't realize this until after I ran all of this off. All four of these problems are all the same type, where it's all side, angle, side. I forgot to give you one with the side, side, side. So what I'd like you to do on this sheet, where I put mine on there, cross off number 4 real quick. And then on the back, I'd like you to draw this picture. Don't do number 4, do this one instead. That way you have a couple of little practices of each style. And again, you'll solve the whole triangle out. All right? Does that make sense? So the first ones, you'll have, the first three are just all side, angle, side. Those are really straightforward. Find the side opposite. Then this one's the more difficult of the two. Yes, ma'am? Yeah, whenever you have the triangles like this, I'll have you find everything. Okay? Yeah, here you got to find the angles A, B, and C. That's really easy to figure out. All right, the rest of them I made sure I labeled them out for you. I put the lowercase stuff in there. I rewrote it in there for you. Okay? And we'll go from there. I told you, you don't worry about memorizing these things. You have to make sure you know how to use them. That's the whole trick. Okay? I know when to use what and how to set it up.